Okay, great. So we are very happy to have two speakers today, actually two for one. Shiv Kalyanaraman and Srinivasan Iyengar. Shiv is the CTO of the energy industry Asia at Microsoft, and he has had quite a long career in all sorts of areas, starting with computer networking, which I first met him in I think 1995, which is now further and further away in the past. Was a graduate student, but since then he's been a professor at Rensselaer Polytechnic. He was at IBM Research in India, then in Australia, General Electric, and now he heads um, the technical side of things at Microsoft's energy businesses in Asia. And I was just talking to one of my students, what does Microsoft have to do with energy? And we found a lot about it, but essentially these days energy is all about data, and access to data is really what we will be doing. So looking forward to that. And he'll be joined by Srinivasan Iyengar, who is also a senior program manager at Microsoft Energy Industry team. He was a postdoc in the Microsoft Research India lab and did his PhD at UMass Amherst. And I also met him as a grad student. So it just shows you how old I am. But anyway, without further ado, thanks so much, Shiv and Srinivasan, for your doing this talk. I know it's quite a bit later in where you are. You're doing this talk from Bangalore, and it's all yours. Thank you.
Okay, first, thank you, Keshav, and thanks to everyone for your time. I hope you'll find it interesting and thought-provoking. On the left is my LinkedIn QR code if you want to connect. So first, before I get started, so this work with lots of folks over the last few years, which includes both Microsoft Research here in India, as well as in Redmond, as well as lots of other folks across business units and so on, right? So, I'll try to put together a story about what we think of in Microsoft as how we can help the transition to clean energy and where AI can play a role, right? So that's the short talk. Of course, you have a couple of parenthetical comments here, 24/7 clean energy and GenAI. I'll try to keep, far away from buzzwords, but, I just had to include GenAI. And I remember Keshav once telling me that we have to be buzzword compatible whenever possible.
Compliant, fully buzzword
compliant. There we go. All right. So that, so I'm preaching to the choir here. This is sort of general opening slide. As you know, if you want to make a dent on GHG emissions in the pursuit of managing climate change, you have to address the emissions coming from energy more broadly defined. And the biggest vector or pathway for energy decarbonization is the combination of electrification of energy away from fossil fuel sources and decarbonization of the grid, which and the supply side of the grid, particularly of moving to very high levels, 80% to 100% of renewable energy supply. By renewables, I also mean more broadly, including storage, etc. And it's going to be increasingly accompanied by a digital energy transition to really orchestrate all these diverse assets, which happen to be distributed, intermittent, and the like, right? So as a result, we expect that there should be a huge demand increase in the demand side of electricity, electrification demand, and on the supply side, shift away to a mix of renewables broadly defined, right? So that's the general outlook. This should not be surprising to anyone here. Again, another straightforward observation, but perhaps driving more towards the case for digital and AI, is that the era of cheaper and cheaper renewables will continue, but increasingly the renewables have to get smarter. What I mean by that is that the last 10, 20, 30 years of renewables has just been incessantly driven by better learning curves, as well as driven both by financial innovation, as well as project management and supply chain efficiencies, as well as policy support. But as we go up the S-curve, the fraction of renewables compared to the rest of the grid, as it increases, by definition, the rest of the grid fraction reduces, and that means that the volatility of renewables becomes far more dominant. It becomes almost like an externality that is imposed on the grid. So to manage that externality becomes the primary challenge going forward, right? And what that means at a very extremely simplified level is you need to instrument demand, you need to instrument supply, understand demand, understand supply, predict demand, predict supply, and match them at various time scales, and orchestrate your electrons so that way you can maximize the value, and so that it is useful rather than being either thrown away or monetized cheaply. Right, so that's the general idea. And the reason this is important is because if you do not monetize your electrons well, the financial case or the return on investment case for renewables will collapse. And if the return on investment collapses, no amount of policy support can hold up or drive the deeper penetration, right? So it's almost like a self-limiting requirement that you have to solve for this. And solving for this is, as I said, instrumenting demand, supply, orchestrating all of this. This is really a digital problem. And the more you want to be smarter about it, there's really an AI problem, right? So the case I'm trying to make is that renewables going forward, or clean energy going forward, is as much an AI problem as it is a hardware problem or a cheaper problem. So you have to be more smarter and cheaper, but most likely the smarter is going to matter a lot more. Okay, so that's with that. Then the next question that will arise is, okay, if I want to do deep renewables integration, it should be accompanied by digital cloud and AI. So what exactly does that look like? What exact AI do we need? What are the building blocks that would be helpful in a AI-defined renewables future? So we think that a collection of blocks that we have outlined at the bottom could be one starting place. One on the starting from left to right. One is the instrumentation of demand and supply, but also creating simple transactions that record demand and supply as being matched. In other words, in a 5-minute interval, I have recorded that here's the demand I have produced, I have, and here's the supply that matches it. And it happens to be from green sources, right? So that's a record that's being created. And that we believe will become a new transactional infrastructure for energy trading, sort of new sorts of policy support and things like that, right? So initially it started off with hourly matching, but increasingly it's going smaller and smaller. Yeah, go ahead, please. Do you have a question?
No, I was just coughing, sorry.
No worries. Yeah, and feel free to stop me at any time if you want to ask a question. So the one is at the far left, it is really a digital, or I would call it more like a data keeping or a record keeping type of innovation. But increasingly, we are seeing that that sort of basis for settlements, basis for trading is becoming more and more important, right? So, and you can have a bunch of analytics around that. Beyond that, the fundamental building blocks we think are the ability to forecast in more and more time scales, and finer and finer spatial resolutions, all the way down to individual assets and behaviors and things like that. Because in a very asset-intensive asset-intensive industry like renewables, most of your capex, most of your life cycle cost is actually dominated by capex. Then opportunity costs become the most important thing. What I mean by that is if you put a lot of capex and your opex is fairly low, if you do not produce revenue, you're leaving a lot of profit on the table, which again means you're leaving a lot of return on capital and free cash flows, etc., on the table. So therefore, the purpose of a lot of AI, whether it is to detect anomalies or to forecast, etc., right, is to ensure that you can produce the maximum you can, number one, or the optimum you can, and B, you can manage the conversion of that production to dollars or euros or British pounds as well as you can, right? So I think the purpose of all of this is to convert uncertainty to risk, but really it is to manage the risk and manage both the production as well as the monetization of renewables, right? So I think that's the key observation I'd like to place here. And the next building block we think of is more and more autonomous decisions to monetize, to orchestrate assets, to orchestrate not just a single farm's assets, but a portfolio of assets, solar storage and so on, across a region, etc. Energy trading, virtual power plants, what have you. All of these can be posed as essentially optimization type problems, but increasingly you can do data-driven optimization, which is nothing but reinforcement learning and the like. Under uncertainty, right? You have to take decisions under uncertainty with financial penalties and financial impacts, right, on both sides. So the players who master this craft will end up having higher returns and lower risk, which is again the definition of what it takes to drive further investments. See, one of the important things I've learned since I was a student is that if you want to drive greater penetration of renewables, you need greater investment into renewables, and greater investment is almost directly correlated to the expected returns that you can drive, right? And if you want to drive greater and greater expected returns, the only way you can do that is a greater investment in software and unique intelligence that you're going to have, right? So I think that's the driver of these two blocks, forecasting and decisions. Then beyond that is all the GenAI stuff that's taken over more recently. As you have more and more farms and more assets in highly distributed settings, how do we enable natural and multimodal interactions, whether we are interacting with humans or assets, or how can remote operations centers transform, and have multilingual, conversations, things like that, right? And richer access or symmetric access to intelligence on both sides of the field side as well as the remote operation side, right? So these are the kinds of problems we are grappling with, and really the GenAI role here has democratized a lot of pieces of this puzzle, and we are rapidly pushing the envelope on some of these areas. And finally, I want to talk. Yeah.
A quick question. So do you view the GenAI as essentially a query engine?
Yeah, I look at it in two parts, right? One is it lowers the bar for interaction, which is the user interface through more natural language, voice, and so on. So the ability to interact and with much more easier in your own, you can speak to it in your own language, things like that. That's one aspect of GenAI. The second aspect is at the back you have you have foundation models, you have multimodal, models, things like that. Or you're able to synthesize insights across multiple modes. Right? So that is the second aspect. Right? So these are two independent aspects of GenAI, which comes together.
Thank you.
Okay. And finally, we think that the cloud becomes smaller and smaller. Like Microsoft is putting out a large number of new AI-centric data centers, and some of these could be presumably smaller in the future as well. So we think that over time, some of these data centers will go directly into renewable farms and start providing two types of services. One is compute services for AI, whether it's training, or inference, as well as flexibility services for the grid. So the cloud itself can become a flexibility energy resource. We broadly know how to do this, but increasingly that lever is also going to become interesting. Right? So that's the basic idea of how we think the journey will play out. Of course, there are lots of details on specific types of assets or combinations of assets. Okay, with that, what I'll do is, give you a view of how we are commercially approaching this from Microsoft in the industry. So I should acknowledge that not everything I'm talking about is, what we call like open source or things like that. But we will, and Microsoft is putting out some pieces of these as open source, but some of these are currently differentiated and offered as commercial frameworks to our customers. Right? So the way we operate is that we have the cloud level basic building blocks, which is the basic cloud data and AI capabilities, apps and infra capabilities. These are our generally available offerings, or you can find it in other cloud providers as well. What we are trying to do in our industry is to have a layer of software frameworks on top of that, which are more energy or verticalized capabilities, which, as you can see, these boxes, they map well to the boxes I talked about earlier, right? One box is about forecasting and time series, and the other box is around decision management or optimization kind of technologies. There's 24/7. There is, and the two orange boxes are more in the multimodal GenAI space. One is about, field operations, orchestration capabilities. That also includes some more of the AI agents and auto AI capabilities. And the second one is more knowledge management, dealing with documents of various kinds. And in green on top, we are looking at new solutions or either old solutions that are being refashioned on top of these frameworks, or you can build them ground up as well, which our partners or customers build finally. And then at the top, you can think of final applications that are sort of surfaced as co-pilots or what have you, right? So don't pay attention to it too much on the specific names and terms here, just as a smattering of examples. So for example, with forecasting, you can have a solar forecasting module or a copilot or a digital twin copilot would be one specific application using the forecasting framework. Similarly, a multi-market trading or an optimization copilot or a monetization copilot would help a customer make more money on multiple markets by using a portfolio of their resources that uses a combination of decision management and forecasting. So that's the way we think of these as more like industry Lego blocks, which could help as a foundation for the future. Right. So I'll keep going unless feel free to pause me. But this is, I would also add that this is work in progress to a large extent. So we are continuously developing these capabilities. Some pieces of this are open source. For example, the geospatial AI toolkit is open source from Microsoft. There are a couple of algorithms like the DeepMC algorithm in forecasting is open source. So there's a bunch of things that are open source, but we are also packaging it and making it more industry specific here. Okay, we hope to do more in the open source and academic community, but we've been so focused on getting this out in the market right now. Okay, so what I'll do is I'll give you a flavor of this, a couple of these GenAI things, starting from right to left on that previous diagram. And I'll then hand it over to Srini, who will take you through the second half of the presentation with more of the forecasting, decision making, and other capabilities. So when we think of multimodal GenAI, we think of each of these modes like our human senses. The ear can hear, the eyes can see. Each of these modes itself, you need some intelligence to make sense of what you hear, right? You need some intelligence to make sense of what you see. But I think a larger intelligence is about both fusing these insights across these modes as well as reasoning across these modes, right? So, and then finally taking action. So I think just taking this sort of very loose analogy forward, we may have specialized tooling for any individual mode. It could be traditional deep learning models or new emerging, foundation models in some of these areas. Time series, for example, has been very hard for some of the foundation models to crack quite yet, and transfer learning has been quite a challenge. So there we do a lot more of traditional deep learning. In areas like vision AI, we are starting to see a lot more of foundation models, but it's a bit earlier than traditional or natural language type areas. And there is also all kinds of other aspects of vision, including graphs, diagrams, video, images, and so on. So we are systematically going into different aspects of that, and I'll give you some ideas of that as well. And ultimately, on the control side, it's a combination of forecasting, optimization, and so on. And then, if you then handle all the non-functionals together, that is, compose all of this and tighten the screws on, how quickly you can do it end to end and so on. I think that starts becoming more of fully closed loop. And if you allow it to be, less human in the loop, it becomes more autonomous, or more human in the loop, it becomes, humans expert-centered models. Right? So that's the idea, but there's a long-term partnership we have with Microsoft Research in the space. So let me start with something you may have seen if you've used ChatGPT Plus, this subscription where you can also add images and so on. So if you just give an image of this sort, this is an example from health and safety, where you get a fairly detailed description. This is a deep image captioning example. And you can ask, you can prompt it by asking, like a business question or a health and safety question. For example, in most health and safety situations, there is something called a job hazard analysis to Today, much of it is done through periodic inspections and so on, but with surveillance of these videos as well as the video captioning, you can have almost live or near live job hazard analysis, right? So here, there's a very simple idea of a job analysis report. So where it, if you look at some of the underlying text, it gives some reasoning of potential hazards, and based on either the boom, the lifted load that could potentially swing, or there are some trip hazards and things like that, right? But there are more structured or semi-structured forms of these reports, or multi-language based reports that we are starting to see. So this deep visual understanding is allowing us to become more proactive in these health and safety type scenarios. And this is an area where we are spending a lot of time working with our customers. The other area is in terms of assets, where we're not talking about people, but assets, and you have different kinds of images, and all you have to say is you're an expert at this, be precise in your guidance, or you ask it to give guidance in a specific way. But then you get fairly interesting insights. In this case, it picks out all the anomalies in this thermal image, and it is giving also like a rank ordered set of actions that you'd like to take, which is what you might expect in a anomaly detection type scenario. And here it does not draw the bounding boxes out of the box, but with a bit of vision assist, the bounding boxes or semantic segmentation, instant segmentation, all of these can be done as well, right? So the one
These
thing
are solar panels, right? What are these?
These are solar panels, yeah.
Okay, thank you.
Yeah, solar panels. This is a specific depiction of infrared image, right? I mean, basically an IR camera. Okay, just zero shot, detection, zero shot conversation with GPT-4. Okay, so the vision AI and reasoning. So, but more generally, what we see is that we have these multimodal agents able to do different things. But I think if you broaden the aperture, you have different algorithms which can work very well for different things, right? For example, you can have a separate model for just depth detection. You can have a separate model just for semantic segmentation. You can have some for just drawing boxes, object detection, some for deep captioning, and so on, right? So you could have specialist set of models as opposed to a generalist model that can do everything. And increasingly, a pattern that we see is the idea of getting multimodal inputs from the user, either implicit or explicit, combination of natural language. It could be through speech in their own language, image or references to time series of sorts. And then you can then give that to a planner, which can then choose models to execute and then generate responses. Now, it is fairly well known that LLMs are not great at planning, but increasingly you can have models like planner and critique type systems, which can increase your effectiveness of this. But what's interesting is based on the, either a simple planner or a multi-step planner, you can build these things like task graphs. And every element of the task graph is either a model or a plugin or a tool or even human inputs, right, to provide guidance or human in the loop. So this is a framework we call genAI orchestration framework. We increasingly think that there's going to be agents and sort of agents with human supervision that can be done. And we look at areas like vision, geospatial, or even other textual analysis as individual components which we can orchestrate through this. Right. So based on this, we've been starting to build, sort of framework components or sort of archetypes of things. So here is like a chatbot archetype, a multimodal chatbot. So you can have a chatbot where you can speak or talk or give text inputs and other image inputs or other sorts of inputs, like from APIs, like from drones or from IoT data or digital twins, what have you. And then what is interesting in this is not just you're giving a couple of inputs and getting an answer, but behind the scenes, the orchestrator is actually coming up with a plan for what to do. And based on that, it can adapt or do other things with the plan. And then it's choosing specific models based on API specifications and preferring certain models, such as custom models over generic models. And then it is also driving action, right? So this is almost like an end-to-end autonomous system loop that we can specify through this. And of course, you can make this tighter and tighter based on the kind of interfaces you'd like. So this is a simple archetype of this. And so this is when we say a framework. For us, the framework is Lego blocks with which you can quickly put this together, and then you can drive any sorts of applications around it. Okay. So another example is we look at field operations with your own language. So I don't know whether the audio will be visible, but we can come through. But let me just make an attempt. There's a Hindi copilot where the guy can ask a question in the local language, in this case Hindi. So it's exactly the same workflow as the earlier one, but the key difference is that, it's a spoken example. Let me know if the audio comes across, otherwise I will skip it.
Okay.
Just give me a second. Okay, right now there's no audio yet. So somebody who's walking through a petrochemical factory, and an engineer who comes across a piece of corroded equipment, and the audio, can you hear?
Not yet. No, we can't hear the audio.
No need to hear.
Oh, you can't hear the audio? Okay. Okay, that's too bad. Okay, but let me, that's okay. I'll just skip this one. But this is an example where you ask a question in your local language, in this case Hindi. It goes to a copilot, which is in the cloud, and it is doing both translation or querying directly in the local language, and getting, and you have a plan that is being created for solving the problem, along with analysis of an image. In this case, an image has corrosion in it. And it does not just a simple classification, but also mapping severity, things like that. And based on that, what is the steps that somebody has to take? And response is also spoken back in their preferred language, right? So we've done it for a couple of languages, and we can do this for many more going forward, right? So this is sort of harkening of a future where you can have lowering the barrier for remote operations and getting solutions. So really remote problem solving using these copilots. Right. One of the things that we've seen is that okay, there are some limits of this. You can there's another example in solar. I'll move on from this. It's not just about solving problems with AI in the backend. You can also have to deal with humans and doing that in a rich interface. I'll talk about that shortly. But another class of problems that we feel are going to be quite interesting is, multi-step vision problems, where you have different to solve. This is an example of a problem where you're trying to figure out if somebody is in a danger zone in this particular scene, right? Is there a health and safety risk, for example? So here, to solve this, it is not just a simple object detection of various people, but also you have to detect other objects. In a cluttered environment, you have many objects. And you have to work out which of these objects are actually potential hazards. So you have to filter down to potential hazards. And then once you've identified these potential hazards and the relationship with humans, you have to analyze the depth relationships and height relationships with them, and make a judgment of, where there could be a potential area of danger, right? So if you're not in this image, for example, naively, this person looks like he's under this load, but if you do a combination of depth analysis and projection, you work out that the person is not in danger. Right. So, so this is exercising different types of vision. Each of these are using transformer-based or pre-trained models, and you have to string together a workflow for this, right? So you can now do this in a video setting. So let me quickly show a video. This one there's no audio, so hopefully it will play. Hopefully, are you able to see the video at least?
Yeah. Yeah, we can see that, yeah.
We make it full screen. So this is more of an augmented video in your real time, where you see both, the semantic segmentation, hazard identification, as well as the relationship between people, and then alerts if somebody is in the red zone, for example, right? So this, gives an idea of a future where, and these models used to be quite difficult to build because it required a lot of training examples. as well as it would be quite brittle because these environments are quite heterogeneous. So a model developed in one situation would find it very difficult to generalize. In fact, we have played around with some of the simpler models like YOLO and so on, which struggle in these sorts of situations. So the foundation model approach tends to be a bit more robust, even though it does need to be customized for these scenarios, right? So what's interesting in here is like this now a workflow, which has multiple steps, and it involves different types of vision tasks. Okay, now we can put this all together also where a human talks to another human, but is assisted by insights coming from each of the modes of AI in this particular situation. So there's a piece of work we did with a Japanese client, and so they have all their documents are in Japanese, but their remote assistance folks could be speaking a different language like English with a site supervisor or site person who is in Japanese. So there's a multilingual conversation possible. And they're being helped by insights coming from a ChatGPT-like session in their local language, sometimes in Japanese. And of course, other things like digital twin insights or time series insights and so on, right? So what this shows is a picture of both rich remote operations and remote operations where you're trying to solve a problem, where you're trying to have a more symmetric view of the insights on both sides. Typically, in today field operations, you have an asymmetric view. Somebody in the field does not have all the information on their fingertips, whereas the person who's in the remote operations center does not have a good view of what's going on in the field, right? So the ability of video and all these other modes to bridge the gaps allows you to have a symmetric view, and this sort of this metaverse is just a place where they can come together and solve, right? So this is a specific choice made by folks. Okay, so I'll wrap up this section, and this gives you an idea of how rich remote operation centers could evolve going forward. This we think it's important for these remote operation centers to be far more effective because you're going to have thousands of millions of farms which have to be operated, and very few people relative to the assets. So increasing, sort of robotics and autonomous operations, when whoever is on the field, will be a generalist, and they need to be supported by highly trained specialists remotely. Right? Okay, with that, over to you, Srini.
Yeah. Can everyone see my screen?
Yeah, yes, thank you.
Okay, so let me continue from here on. So next I'll be talking about something called as the Multimodal Enterprise Knowledge Advisory Framework. I understand that name is a bit mouthful. So let me motivate it through a problem. So imagine that you are an energy trader for a renewables company. You have a portfolio that you manage, which includes maybe a solar farm, a wind farm, and an energy storage system. What you want to do is to have a co-pilot with you, which can answer some of the questions about how to bid in the markets, right? So the energy trader might ask a question if there are any supply chain disruptions. Because of those supply chain disruptions, maybe the coal stocks in some thermal park plants are going down. That may lead to spike in prices. So that gives you an opportunity to bid in more power, more energy into the market. Similarly, you may want to know what is the weather at certain hydropower plant locations, because if it's going to be excessive rain and if the elevations of the reservoirs are pretty high, that means they have enough water to generate a cheap hydropower, right? Or if the opposite is true, if the water levels are running low, that means that the hydropowers cannot come online, and that would be an opportunity for you to bid in the markets. Simultaneously, I of course want to know what are the prevalent energy prices, right, in the past week or so. So if you look at it, for me to build such a system, I have to interact with a knowledge management system which can have access to supply chain information. It should have access to weather information. Additionally, it should be able to query a database of historical energy prices at any given location, right? So the rich interface that we provide, and if we can aid the energy trader, would be great, right? So that was our motivation. And if you look at what we have done with Multimodal Enterprise Knowledge Advisory, we have integrated this system with multiple AI platforms. Many of them are from Microsoft stable, some of them are open source. and different knowledge sources like knowledge graphs, etc., that you can plug in. We know that any intelligence that we want to help or augment human intelligence would involve perusing through different kinds of data, right? Going from everything from totally unstructured data to, say, text from a PDF that can tell you how to maximize your profit based on prevalent conditions, to some semi-structured table in some PDFs, or maybe some images as well, right? Also, as Shiv spoke about like complex site operations, many of these asset-heavy industries have what are called as process and instrumentation diagrams, which can actually spec out the whole plant in 2D diagrams. Now, before even building those plants, you may want to query if this particular plan makes sense. For example, if you're building a heat exchanger, you may want to make sure that there are temperature gauges both at the start and end points of this heat exchanger, right? Similarly, if you want to have a compression mechanism, you want to, of course, have a pressure gauge at the end, right? Can I query my PNID diagrams to see if it is compliant with what I want to ultimately have, right? And this interface allows you to, of course, try to post different kind of queries, right? How can I query engineering diagrams? Can I ask analytical queries to a system where the database is not just having a standard database, right? It could be, as I said, free text, PDFs, video, audio, all kinds of data at their disposal, right? To build such a system, we know that we have to be agnostic to different technologies, right? So the generative AI space is moving very quickly, and we are not picking any winners out here. So to build a chat or a search bot, I need to design the system by choosing one out of each of these colored boxes, right? I have to choose what kind of LLM model to use, what kind of knowledge base I should use, what are the vector embeddings. And to be honest, there are no clear correct answers out here. The answers depend on what are the cost you are willing to put up with, because each of them hosted on cloud will cost a lot of money. Second important aspect is latency. How fast you want a response to come back to you. Maybe, for example, if you are looking at remote operations, that the example which Shiv gave, in that case, you may want to ensure that you get a response within 3 seconds, right? That could be the latency upper limit that you can allow, right? And third thing could be complexity, right? As I mentioned about an energy trader copilot, right? I have to really have complex interfaces with different kinds of data, supply chain data, weather data, or even databases from energy exchanges, right? So in our system, what we do is we have made it extremely configurable. You can have a choice of your LLM model, your knowledge base, your RAG techniques, your LLM agents, and you can build a chatbot very quickly, right? So clearly, if you can see, each of these boxes have some 3 to 5 choices. So combinatorially, we can create hundreds of different varieties of chatbots based on your cost, latency, and complexity constraints, right? And similar to machine learning life cycle, right? So any machine learning application, you would know that initially you have to clean the data, then you have to do some exploratory data analysis, then you enter a modeling phase where you train the data, and then you deploy the system in the production, right? We have a very similar life cycle for a knowledge management system. Initially, there is a document cracking and index management phase where a data engineer essentially makes sure that the data is inputted and it is stored appropriately in your system. Note that with any of such systems, it is garbage in, garbage out, right? So if you have a complex PDF containing images, tables, and free text, you want to ensure that you are cracking this document and appropriately treating them differently, and you have different processing pipeline for each of these data types, right? Second is where the magic happens. The data scientists can make some choices that I described in the previous page, what kind of LLM model to use, what kind of knowledge base to use. And based on that, the data scientist can create several custom profiles, right? I can create a profile for an energy trading application, I can create a profile for remote operations. I can create a profile for sales and accounting kind of an data as well, right? By that, I mean, rather than pointing my LLM to the entire world's knowledge, I can ground my LLM to just look at some data that is at my disposal and give a better answer to the user rather than hallucinating, right? And finally, of course, we have the users who can put up their search queries or chat with the system. And optionally, you can have a monitoring interface, which could be a passive monitoring interface where you look at telemetry data, noting how well the users are engaging with your chatbot, or you can have a much more active monitoring setup where you do some A/B testing. You directly ask the user if the responses that this chatbot is giving you is making sense or not, right? Yeah, so that is about enterprise knowledge management. Second framework that I'll talk about is called forecasting. Now, forecasting is a very, especially time series forecasting is a very common problem in the renewable space, right? First of all, your energy supplying systems like solar farms or wind farms are dependent on prevalent weather conditions. So of course, they cannot produce energy on demand, right? So if you want to bid your energy into the markets, you want to know how much energy you are generating, say 24 hours from now, right? So that you can maximize the profits by from your solar and wind farms. Also, you would like to know how much demand of energy there is, right? How much load is going to be consumed by people in the next 24 hours, right? And finally, you also want to predict the prices, right? So if you want to make, I want to maximize my profit, and if the prices are low, it would make sense for me to store my solar and wind energy into an energy storage rather than directly bidding in the markets. Vice versa, if the prices are very high, I will ensure that not just I'm selling all my production from solar and wind to the market, I will also make sure that the energy storage is also selling to the market to maximize my profits, right? And of course, while building this framework, we have support and custom features for each of these entities for demand forecasting, solar, wind, and price forecasting. We made sure that it is generic enough, right? For example, if you want to bid in a day-ahead market, that is, if you want to make sure that you are telling the energy market that what I will generate 12 to 36 hours ahead, but there could be another market where you want to tell the market what you would be generating 1 hour from now, right? So we provide forecasts of different granularity, different time frames. Again, similar to the last framework that I spoke about, we are agnostic to the technique that we used. We have integrated open source technique from Google called TFT, which is a very good time series forecasting model. We have also integrated another open source model from Microsoft called DeepMC. We have seen that it performs quite well. And also we have made sure that we can take diverse forms of inputs, right? We can take weather forecast input, some, again, domain expertise about these different topics. And of course, we can integrate with different kinds of streaming data that we have, right? So let me quickly talk about some couple of use cases that we worked on, right? So this is actually a wind farm located in South Australia. It's called Hornsdale Power Reserve and Wind Farm. Essentially, what this exercise shows is that if I want to do better forecasting of wind energy or solar power for that matter, you need to have a fusion strategy of better models and also better data, right? So if you just blindly apply without having any domain knowledge, you blindly apply one of the top open source models called TFT, you will perform rather poorly, right? As you can see, the model is somewhat following the trend, but overall it's doing a very poor job of predicting what would be my wind energy that I'll be generating, right? But if you combine that model with some exogenous variables could be weather forecasts that are available from third-party sources, there is a significant improvement in your forecast, right? Moreover, if you have better models, time series models, you can get even further improvement in your forecasting, right? So in the bottom right corner is basically the DeepMC model that we have. combined with exogenous variables, which gives you the lowest error or the highest accuracy, right? Again, I'll take another example of a real world use case. The previous one was done on an open source data. Here we worked with an American utility company. They wanted to predict the energy demand in one of the states in the US. And of course, they had a significant amount of data. They also had their own forecasts, different forecasts that we could leverage, right? So here we tried to ensemble the different forecast models that we have to further improve the results, right? Similar to the last slide, we augmented this data with external third-party weather sources. And also we applied a lot of domain knowledge, right? So the degree days model that you see out here, it's just a fancy way of saying that when your temperature increases, your cooling requirement goes up, and that's why your energy demand increases. When the temperature reduces, of course, you have heating requirement, right? You have to heat the environment, and again, your energy demand goes up, right? And there is this median in this middle region where your energy demand is very less, right? So this kind of model has been existing for multiple decades now. What we have done is that we have applied it as a feature and also added some more domain expertise, right? For example, if you want to predict the energy demand in an industrial setup, industries tend to have very complex HVAC systems. For example, if the temperatures are higher, but the humidity is lower, you can do away with evaporative cooling, which requires much lower energy demand. Whereas if the humidity is high and if the temperature is also high, you may have to turn on air conditioning units, right? So we apply all these kind of domain knowledge to make sure that our accuracy improves, and we got around 1.5% of mean absolute percentage error in predicting energy demand 1 to 24 hours ahead, right? So by knowing how much demand there is, I can better bid in the energy markets and maximize my profit. And if you notice what she mentioned at the early part of today's session is that all these renewable players have to be smarter to make sure that they can monetize their asset properly, right? Just to highlight one more aspect in time series forecasting, right? So this time series forecasting is a very old problem. People have been doing time series forecasting for past 7-8 decades, to be honest with you, right? But earlier models were not that rich in the sense they could not, they had very poor predictability when including more and more complexity in the problem, right? And also, whenever we talk about an ML or an AI system, right, typically people think of, a training data, test data, and how I have code associated to make use of that, right? So actually the core ML code is a very small part of any ML system. You need to have a data collection setup which can clean the data. You need to have a feature extractions module which can make this data ready for the ML models. You need to have data verification steps so that you ensure that there is no data drift coming into the system. There are lots of configuration hyperparameters. You have to continuously monitor if your setup is giving the right output. Also, there is a serving infrastructure, right? Ultimately, it has to be deployed in production. And you have to continuously analyze if the predictions that you're coming are making sense or not. So just to highlight that ML, when we talk about an ML system deployed in production, it is much, much, much more than a simple ML code, which could be a very small part of the setup. So there is a lot of hidden technical debt involved in building these ML systems. And what we have done through the forecasting framework is made sure that this hidden debt is reduced for our energy customers in this space, right? We handle all the ML ops that are needed to assist you in the entire ML lifecycle that you see out here. Just to finally finish off with another one of our frameworks called decision management. Now that I showed that I can forecast how much I will generate, but the next question is how to bid in the markets.
Can I just interrupt you for a minute? We need to end in a few minutes.
Yeah.
Already shown us lots of very interesting data. I know there's quite a few people with questions here. So could we skip this bit, please, if you don't mind, and take time for questions?
Sure. So just to finish off in one sentence. So essentially, this framework just allows you to use the forecast that you got from the previous page and apply it in different optimization problems. And this framework essentially allows you to build these different optimization problems in a very, very short time, right? And we have applied it to several settings like a multi-market trading opportunity or a joint optimization problem for a hydro dam network, right? Right. So that's it from my side. I think Shiv can finish off with this.
So happy to take questions. Yeah, maybe we'll get off video and get off this presentation. We can.
Yeah. Thank you very much.
Yeah, stop.
Okay, questions in the room? Yes.
Hi.
Stop the screen sharing.
Can you hear me?
Yeah, please go
Yes.
ahead. I'm just requesting to stop the screen sharing so we can see you. Yeah.
Oh, start the presentation. Yeah, thanks, Jim.
Yeah, go ahead, please. Yeah.
Hi, thank you so much for an amazing talk. The presentation touched on a huge discrepancy I found in my research on renewable energy and AI, which is, should the focus be more on designing AI, which can make all the decisions for us, or designing really good user interfaces, which will allow kind of backroom operators to make better decisions? Because I've kind of seen a split both ways, and I'm wondering which way we should be leaning.
My comment would be that it's not an either or.
Yeah.
It is going to be, there's user could be, the consumers, at on the demand side. I think that's one aspect where you can modulate demand and be smarter about when you consume. Okay, so and you can respond to signals, right, economic signals or otherwise. And then, any of these interfaces, whether it's natural language or speech or all these interfaces, should aid in that process and give you the right nudges and behavioral nudges to help you there. Similarly, on the supply side, I think there is operations where we focused a lot more on remote operation centers, helping folks in remote places to solve problems, because opportunity costs of not producing are drive the economics of this. So I think that's the other part, right? But almost everything in between, we think AI can intermediate and help. But also the user interface transformation could also be helpful in our view. And we just gave a few examples, but I think there's a lot more to be done.
Thank you. Any other questions? Yeah, go ahead, Billy.
One that came to mind is it's really interesting how large language models and foundation models are kind of forming the core here of a lot of these user interfaces and this kind of orchestration problem. It seems to me like I think historically in AI the research approach has been these kind of bespoke applications and building a model for a problem, and now we're doing this more top-down approach. What seems to kind of concern me is that you bring along the biases of any foundation model that you build multiple applications off of. So for instance, in the example of building a personalized multimodal like chatbot for different applications, it to me is kind of concerning that, okay, I'm building it on top of ChatGPT, and all of a sudden we realize that there are these kind of biases. And now that exists in now all of our products. I wonder how, I guess maybe the solution then is just to be modular. And so as you discover those biases, you can kind of take it out and put a new one in. I wonder how you deal with having kind of this common element that potentially can kind of augment biases across products.
Yeah, it's an excellent question. I think whatever we do nowadays, we have a process that we go through something called responsible AI. That is a review that keeps happening based on all the use cases. Every projects we do, we have to do a deep responsible AI, and then if the our reviews are not satisfactory, they keep there is an ongoing review as well. So that is one mechanism. I'm not saying it's a foolproof mechanism. That's number one. Number two is that we are using a variety of models in many of the things that I talked about. We have a combination of some of our internal models, whether it's a Florence model or GPT-4V or what have you, as well as external open source models as well for specialized things. And at least at Microsoft, we are looking at just picking the right model for the right job, so we expect to be using a combination of these models, so that way failure mode in one model that doesn't become too endemic, right? And also the architecture is modular, so you can always swap in and out some of these models. But I do see the risk, of course, if you have a highly fine-tuned or customized model, it becomes harder to swap out, right? So there are some of those more economic trade-offs. But look, I think I don't have a silver bullet answer for you. It's something we just have to pay a lot more vigilance towards. In our area, at least, we've been focused a lot more on assets and lesser of people interfaces. So anywhere you touch humans, I think that becomes a lot more important for sure.
Right. Thank you.
Okay, I have a question for you as well. So, I mean, I was just struck by the way in which what you're doing here is to have the actuation of essentially AI-derived plants in the real world. For the corrosion example, or what might be a nuclear power plant, right? So this requires a tremendous amount of trust in the results from the AI system. And I noticed that provenance as one of the elements in your framework, but provenance alone isn't enough. Provenance is also to find out what went wrong when it goes wrong. But in some sense, the reason why we get a consultant or an expert to advise on how to, remediate a nuclear power plant that has a leak is because these people have expertise, domain knowledge, and more importantly, they have insurance, they have coverage in case they make a mistake. How does that play in your world? Microsoft decides to give advice on saying, okay, tighten that, that bolt to 20 nanometer, whatever, 20 Newton meters, because that's the right tension for this bolt. And it's actually off by a factor of 2 or 4, and the reactor breaks because of this. Who takes responsibility? How can you be sure you got the right answers?
Yeah, as usual case, you ask the hardest questions. Look, I think right now I would say that the degree of human in the loop or layers of reviews or human trust, oversight would be more for those sorts of critical systems. Whereas the systems we are focused on is where insights have been hard to get. And there's a lot of natural language or vision or other data lying around, and it's sort of we've been looking at some of the low-hanging fruit, and to be able to compose these insights and make it useful. As we go further, there we see these as co-pilots, which means a human in the loop or expert in the loop systems. So then it's just a matter of how many layers of these expert reviews or sort of the best practices, learned from running such facilities like nuclear plants and so on and so forth, right? So, you have to assume, like any other unreliable system, right, that you're going to get unreliable outputs. It's just that the incidence and catching when exactly that unreliability is becoming a bit more harder with these systems. But Srini, do you want to add some more?
Yes. So Keshav, the HSE example that you saw here, right? So in that case, currently, actually, it's like a human basically looking at a camera, right? And that human might be looking at 20 camera streams. So that person is really overwhelmed to do anything at this stage, right? So the state that we are proposing is to at least improve on that so that their attention is better utilized on clear violations where this is happening. So it is an improvement from the current setup where anything goes right in these sites. Whereas what we are proposing is at least we are monitoring it, and even if we miss a few cases, the cases that we catch can have a big impact on health and well-being of people, right? Having said that, more importantly, like the human in the loop aspect is very important, right? We are not saying that this AI is going to replace basic monitoring and other things, right? This is just going to assist the user and help them in taking the right decision or guiding them towards the right decision.
But let me just give you two counter objections to that. I mean, I know we're running out of time. But the first one is that if you have too many false positives, the immediate reaction of the person on the ground is to say, turn it off. They'll discover the camera, turn off the depth sensor and say, I know what I'm doing, don't bug me. Because 99% of the time you're wrong, right? This is what's going to happen in real life. Because you have an HSC inspector, the AI saying, hey, you might be doing this. He says, no, I'm not. I know what I'm doing. I've been doing it for 35 years. Stop, right? Yeah. They will pull the plug. That's what will happen in real life. You know it and I know it, right? So it's the second thing, the trader example is actuating. So you have a trader, hotshot trader, just graduated from Cambridge, got a job in trading, and have AI with this little airport saying, trade up now, trade down now based on this thing. They can lose millions of dollars in a few days. This happens, all the time. ING Barings, a 400-year-old company, died because of one trader in Tokyo who was doing, I don't know, actually wasn't doing AI, doing something else. But with AI, he can trade Microsoft. Microsoft did it, not me.
No, I think these are excellent examples. And of course, this being a public thing, we want to be very careful on what we say about liabilities and stuff. But I think the broad direction, Keshav, is that I think in cases where you're closer to much more higher stakes decisions, there is higher and higher levels of caution, right? In fact, our responsible AI teams work with us very closely, where any of these things, right, not only can save lives, but you might lose lives, right? Similarly, you might lose a lot of money versus saving a lot of money, and so on, right? So I think the approach is that greater degrees of caution and I think greater degrees of explainability. I think like you correctly said. At the stage where we are, we may not have, there is a little bit of a black box element on and the lack of explainability element. And you don't know when you're saying things wrong and to what incidence rates the current situation, right? So I think a lot more work needs to happen either to understand the statistics and the behaviors of the errors as well as incidence of the errors, in addition to the appropriate risk management on top of it, right? So right now we just put human in the loop and then keep these as more as advisory systems. But I think if you want to go deeper to make a bigger impact, I think a lot more caution needs to happen.
Well, thank you very much. I'd say proceed with caution. That's like it.
Proceed with caution. Yep.
Thank you very much, Shiv.
Thank you so much.
Thank you.
Bye.
All right. Okay. Thank you all. Bye-bye.